Hello everyone. So this is our first lesson on Introduction to C++, and I'll start this lesson with this program. So first I'm going to read this program word by word, and then we'll interpret these meaning of these words. Okay, so the first statement here is that starts with the slash, and that is actually between the, we can say, the slash star and the star slash. So this is the first statement here. So we have a slash star text printing program, and there are two lines here. So within this, and then we have the hash include, and then we have IOStream, and this IOStream is between the angle brackets, which are the angle brackets, and we have here something called double slash, and then we have to print on screen. Some text is written after the double slash. And then we have int represents the integer, and then we have main, and main is something which is has the parentheses also. So this is an opening parenthesis and this is the closing parenthesis, and it also has a block which starts with the opening brace, which is the left brace, and ends with the closing brace. And after that we have some spaces here which is called the indentation, and we can have more space after each statement, you can see here. And then we have standard std, which we call it as standard, and we have a double colon, it is the scope resolution operator. And cout, we have the insertion operator, this is called the double angle brackets insertion operator. And then we have some string, this is called a string. Welcome to C++. We have slash n, and this whole text is within the double quotes, and we have a semicolon here. So semicolon is here, but it's not here, it's not here, it's not here also. And then we have a return, and it's 0, and again we have a semicolon, and again we have the same double slash, and then we have some text here. So now we'll see the meaning of this, the particular keywords that we have used here. So first thing, the comments. So comments can it can have a double slash that we have already used, or it can start with the slash star and ends with the star slash. So anything that has single line comment will be here. Anything that has multiple lines, like 2 or 3 lines, at least 2 lines, so we can use this one. Slash star, we can, of course we can use single line, this one for single line also, but we need to end this with this one. So this has an ending, start and end, but does not have any end, so it is just a single, because it's end, new line is the end of this one, so that's why it's not there. Next, we have used here hash include IOStream, and this IOStream is between the angle brackets. So there are different ways also, but IOStream or different library headers will be within the angle bracket, and hash include. So hash include is our preprocessor directive. So it instructs the preprocessor to include the contents of IOStream into our file, so that we don't have to reinvent the wheel. So something is already written, so we just want those things to be included in our file. So that's the role of the preprocessor, and it executes before the compiler. So compiler will compile the code, it will check for syntax error and will create an executable file. But before that, the preprocessor is going to include the contents of the IOStream into our file. And the contents of this file may be some definitions, maybe some objects, maybe some declaration there. So in case of IOStream, it is essential for something that we want to display on the screen, or something we want to get from the keyboard. And if that's there, we are using that, then we need IOStream. If we are not handling any keyboard or screen, then maybe we may not require for our program. Then white spaces. The C++ program can have blank lines, can have spaces, can have tabs, and everything is ignored. Everything related to space is ignored by the compiler. So we prefer white spaces, we prefer indentation to increase the readability, but C++ is going to ignore that. Then we have integer and main. So integer is something, and then we have that's the return type of main. So main is a function. So how do we know that it's a function? So this parenthesis tells us that this main keyword is a function. So every C++ program must have main. So it's important. So everything that when you run the code executable file, the control starts from the main. So parentheses after main indicate that it's a function. So C++ program consists of functions and the classes. So we can have write our classes also later on. We can have functions, but main is something that is must. That's the one function, and execution always starts with the main function. The main function returns an integer, and it always returns something, and that's written here that it returns an integer, and this integer is actually the we can say it's the exit status. So if the main successfully completed its task, we can say that the main completed the instructions. Then we say the main return 0, otherwise will indicate to the compiler that by return 1. So int keyword precedes main to define its in. So anything that you later on will define our own function also. So its return type will be written first, and then the name function name, and then this you can say the parentheses. And return is a reserved keyword in C++ that we'll use to return the values from the function. The structure of the function in C++ and in most languages is the function body. So we have a function name with the return type, and then we have the left brace, we have the right brace, and the purpose of brace is the enclose the instruction. So these instructions belong to this function. So when you call this function, so these instructions will be executed. So in one of these, that instruction is standard cout. This is scope resolution operator. So it tells that cout it resolves the scope of the standard cout from the standard. So it will use this object will be used from the standard namespace. And we have here the insertion operator, and we have welcome to C++. So anything which is in the double quotes is called a string. So characters between double quotation marks are called strings. By default, the white spaces are ignored by the compiler. For example, here we can have multiple spaces, but any white space between the string is not ignored. So if you have two spaces here, compiler is going to show you the two spaces here. So it does not ignore. And this is called a string you can call character strings, you can call string literals. So every C++ statement must end with the semicolon. So here we have a semicolon. And pre-processing directives are actually not the C++ statement. These are the directions for the preprocessor to replace the command, the contents of that IO stream. So those that may have the C++ statement, and that may have the semicolon. So pre-processing directive or semicolon. So we should not be adding semicolon after the pre-processing directive. And in C++, we have an input stream and output stream. So input stream and output stream means that we want our output to be displayed on the screen. We want our input to get from the keyboard. So for that, we use the output stream as well as the input stream. For output stream is the standard cout. So it will say standard cout hello. So hello will be displayed on the screen. So it sends data to the stream object. And we also have used the standard namespace. So standard namespace is something that is we have used here before the cout. We say always have written standard cout, and we'll use standard cin also. It specifies the namespace. So namespace is one of the way to prevent the name conflicts. Like there may be cout is something that can be used by other namespaces also. So, but when we are using cout from the standard namespace, we'll say standard cout. If you are using it from other namespace, for example, standard 2, we have created another namespace standard 2, and cout may be there, but it has been defined differently. So in that case, we will use is a standard 2 scope resolution operator and then cout. But sometimes it's very inconvenient for the users to every time write using standard cout, but you can reduce that coding. You can say using namespace standard, you can just say namespace standard, then you don't have to repeat for anything names. But this is not a good practice because everything will be included. So this may be still better, right? Using standard cout. So you can say the cout that I'm using in my code is from the standard cout. So And if you have to use any other cout, then you can say standard 2 colon cout. But if you write only cout, then it will use this one. So you can use this statement before your main, and then you don't have to repeat. But just a style is. Next, we have this statement, standard cout, and this is called the string insertion operator. So this is an operator where we have operand on the right side. So the meaning of this one is that the value of the hello or whatever variable if we have, so this will be sent to the stream. So this is going to where the data should go. So hello will be sent to the output stream. And what's the output stream? In this case is our screen. So the direction we need to remember that if it's a cout, the direction will be towards cout. So it is the direct point towards where the data goes. So data goes to the output stream. So that's why the data is moving to this. So it will go to this. And we will see soon. In case of cin, the direction is opposite because the data goes to the variable. So the direction is where the data goes. Okay, so anything that we have displayed written in the codes will be sent to the screen, and we can modify some of the things here with the escape sequences. For example, /n. So /n modifies the way this should be displayed on the screen. So for example, here we have said /n. So /n is new line, so it means that this statement will be printed, hello will be printed, but the cursor will move to the next line. So if you have /t here, so tab will be displayed there. So we can modify with the escape sequences, and there are a number of escape sequences here. So we have /n for the new line, /t for the horizontal tab, /r carriage return, A for alert symbol, and if we want to include slash in the string, then we use the backslash. If we want single quotes as a part of the string, we use slash single quote, and similarly slash double quote. And return 0 is generally the last statement, but return typically is one of the way to terminate the function. So, and you can write in between also. So if you want to terminate early based on your condition, you can say return something, and that returns. So in case of main, this return gives the status of the program. So if it is 0, then we say that it executed successfully, or if it not executed, then we generally prefer to write return 1. And by default, the main implicitly returns, we can say 0. If no return sense, we would not write, then main is going to return 0. So in future program, we can omit this statement return 0. We don't have to write in case the program is correct. Next thing that we want to see is the initialization. So we have declared the variable, for example, and we want to initialize those variables. Let's say that this is n1 is a variable, and we are saying it is equal to 2.5. So 2.5 is the initial value of the n1. So it has been declared an integer, so we are giving this value as a 2.5. And this is another way of declaring or assigning the value at the time of initialization. So we say n2 is also an integer, and its value is also 2.5 in the parentheses. So the difference between these two initialization is, so this is not going to give us an error. So why it should give an error? Actually, why are we expecting actually an error? So we are expecting an error here because this is an integer and we are assigning the value as a decimal point, which should not be there. Or so if it should not be there, then this considers this, but it gives us the warning. So because it should not be there, so it just gives us the warning, but sometimes some of the programmers suppress the warning. So in that case, it will not show you. So it's generally preferred of this syntax. So we'll always be using this syntax because in this case, if we use this one, so this is not going to give you warning. This is going to give you an error. Error means that it will not going to compile the code. So it says that 2.5 should not be assigned to n1. But while in this case, it will give you a warning, but n1 will be considered as a 2. So it is just going to ignore that, and maybe the value is 2. Okay, so let's say that now we want to add two numbers. So in case we want to add two numbers, we have said n1, this way of initialization, we say n1 is initialized to 0, n2 initialized to 0, and sum is initialized to 0. And then we'll saying that we want user to give us the number. So if we want users to give us the numbers, we'll have a statement standard cin, and then we have the extraction operator. So that we will get value from the cin and we'll assign to n1. Since the data is going to n1, so we have the direction towards n1. So that's the statement to get the value of the input. But when this statement is executed, the screen will be blank. So that user is not surprised what he or she is supposed to do. So what we're going to say is before this statement, it will be used, and it says that first integer is equal to. So basically, this prompt will be displayed to the user, and then this statement will be executed, which is actually waiting for the user for the input. Similarly, this one. So after this, the user has entered the number here, then it will say second integer is equal to, and then this is going to wait for a user to enter some number. For example, here I have given is equal to 10 and user entered 20, and then the sum will be computed and it will display sum is 30, and then the next line, the cursor will move to the next line. So there are a number of fundamental types. So integer is some one fundamental type. So there are others like we have the variations of integer also. Like we have signed and unsigned variation of short, integer, long, and long, and these represents the number of bits. So we may have a 32-bit operating system or 64-bit operating system. These bits may change depending on which operating system you are using. But these represent at least the minimum bit. So if it's an integer, you will always get 16. You may get 32, but it's always the 16. If you short, you will always get 16 bits. And long, maybe you can get maybe 32 or maybe 64, but you will always get 32 at the least. And similarly, we have bool, which is true and false. So Boolean values are represented in numerically, and there are ways that we can actually convert this representation as true and false. We'll see in future, next program. And then we have the character, which are the single character, like small a, capital A, 3 or dollar, represented in the single quote. Then we have a floating point. We have a float or double with the floating point single precision, 32 bits, and the double precision, 64 bits. And then we have the long double. So standard cin, this is called the extraction operator. So it extracts something and it gives to the X. So whatever user entered, so it receives that value and converts it to the type of the X. So since X is an integer, so it will convert that to the integer and will give it to the X. Then we can chain these insertion operator as well as the extraction operator. So we can say the standard cout first operator like this one, insertion operator, then again insertion operator, then again. So basically we want to say sum is 30, like sum is a string that we want to display. So it's in double quotes, and then this sum is the value that we want to display, not sum as a string, but we want its value to be displayed. So it must not be in the double quotes. So, but we need another insertion operator, and then we want a new line character, again maybe in the single or double. So we can say use this one, and then we must have the semicolon. In terms of memory, these variables are stored in somewhere memory, and these numbers represent the variable that we create for these the values represent the location of that memory. So we don't have the exact location right now, so but we are referring that location with these the variable that we have created, like n1, n2, or maybe the sum. And there are different arithmetic operators. We may have plus, minus, multiplication, division, and the modulus operator, which is the remainder. And we may have integer division. So if our both the operands are integer, like 7/4, so this is going to truncate everything. So it is going to drop the decimal portion. And if none of these is in floating point, so if it is 7.0 and 4, then it's perfectly fine. But this is not going to give you the exact division here. Similarly here, 17/5 is equal to 3, and there is no rounding here. Similarly, if we can also have a remainder operator, which is the percentage. It can be used with integer operands, and it will give you the remainder after division. We can also we use the exponent operator, which is from the CMath library. So if you are using the standard power function, standard POW, and then we need to say hash include CMath. So we need to give the direction to the preprocessor to include the CMath so that we can use the power function, and then 5 2 means it is 5 square. If it is 5 5, then 5 raised to power 5. And there are operator precedence, as in mathematics we have some precedence here that which operator should be executed first. So we have a parenthesis, and parenthesis will always be executed, but if there are multiple level of parenthesis, then there is no order. And the second level, we have the multiplication, division, and remainder. If they are at the same level, then it's always left to right. And if it's the addition and subtraction, then if the same level, then these are also from the left to right. So that's the first. So this is the first parenthesis. Then we have the multiplication, division, and remainder, and left to right, or whosoever come first. And then the third is the addition, subtraction, whosoever come first, or we can say the left to right. Then we have the relational operators as well as the equality operator. So relational operator tells us the relation, whether the value is greater than or greater than equal to, or less than equal to. Similarly, we have the equality operator that tells the value is equals or not, or value is not equals or not. And the corresponding to these two operators, since this equals has been used as an assignment operator in programming languages, so we use double equals to represent the equality operator. So we say x double equals y means it is going to check whether these two values are equal or not. And as we know that since we are going to check whether it's greater than or less than or equal to, so this all of these values, the result of these expressions will always be Boolean. It's either true or false. Either the two values are equal or not equal. It's going to be true or false. So we can use these conditions because its value is true or false in our if statement. So we can say that, let's say that we got two numbers from the user and we have changed here, the cin also has been changed, and when we just directly say enter two number, we're not saying enter first number and then enter second number, we're saying enter two numbers and then n1 and n2. So user can enter here, for example, 4 and 5, or maybe 5 and 5, or whatever. Okay, so this 4 will be assigned to n1, and after the space, it will be assigned to n2. If there is something you have written, that will be ignored. So n1 and n2, the code, the program got the values of n1 and n2 as an integer. Then it is going to run this statement, which states if n1 is equal to n2 or not. So it is going to compare the values of n1 and n2. So in this case, 4 and 5. So these are not equal. So the result of this expression will be false. So since this is false, so this statement will be executed only when it's true. So since this is false, so this will not be executed. However, when this will be computed n1 not equal to n2, yes, this is true, that both are not equal. So this will become true. And since this becomes true, it was going to display 4 is not equal to 5. And we have used objects like cin and cout from the standard template library, and in the future program, we'll use other objects from the standard template library, but now we'll use from the string library. And when we use the string library, we can, other thing that we can do is like, we can use some input-output manipulators. So input-output manipulators are like, we know that Boolean values, true and false, are represented in the memory as a zero or non-zero. So if it is false, then it means zero, and if it is non-zero, the value is represented. So you can say Boolean x is equal to 5. So that means that you're saying is true. So if you say Boolean x is equal to 0, then compiler is going to consider false. But sometimes it's not very convenient for the users, because if we say we as a programmer we can understand, but the user may not understand that why this is zero, what does zero means, and what does non-zero has to do with true and false. So for that we can use the standard bool alpha or standard no bool alpha. So we can switch between these two. So if we want true and false to be used for cout and cin, we can say using standard bool alpha, or you can say standard cout this and then standard bool alpha. And then if we are using it for cin also, we can say standard cin, standard bool alpha. So it means that the cout and cin will use bool alpha. So bool alpha means that literally true and false will be used. And if you want 0 or 1 or 0 or non-zero values to be used in your code, you can say standard cout, standard no bool alpha. In between also you can change your code. You can say standard no bool alpha on cout or standard no bool alpha on cin. Okay, so in this case, we have used the standard bool alpha, and we'll say enter a Boolean value true and false. The user is going to enter something here as a string true. So this true will be assigned to this flag because standard scene is flag. And then we'll say display this. It is going to display the value as a true here. So it's a you entered true. So now you will do compile this and run this code by commenting this and see what happens. Similarly, next we will use the objects from the string class. So in case of string, now we're saying that cout is again we have used for bool alpha for a cout, and we have initialized s1 with the hello, and s2 we have not initialized, so it means that this is empty. And if we compute the length of the string, so we can say s1 dot length, and we'll say that this may be displayed as a 5 because there are 5 characters here. And then in s2 dot length, since this is empty, so it is going to display as 0. And if we say what is s1 equal, if s1 is equal to s2 or not. So since we have used here the cout as a bool alpha, so these two comparisons, since s1 is not equal to s2, so this is going to say false. The strings are not equal. So that's where the meaning of we want to use here bool alpha, because we want to show the user that it is false, not comparison say standard cout equal to 0. So user doesn't know that 0 means false. Okay, so similarly, here we are saying that if s2 dot empty, so if it's empty, then there are different functions in the standard libraries with the string library. So we can include that, and we can we can use those functions. So for if one of the function is empty, so it is going to check whether the string is empty or not. And if it is empty, then we are assigning s1 to the s2, means that both becomes equal. And there are other functions like we can check whether it starts with particular string or not. So it is going to say HEL, since it starts with HEL, so it is going to true, and it's s2 because we have already assigned. So it means that this is going to display true, and it starts with small HEL. It doesn't start with small HEL because H is capital, so this is going to display doesn't start false. And similarly ends with, so it is going to display its actual representation in the Boolean, which is true or false. So that's all. Thank you.